talking about grid shells. There are two ways you can consider grid shells. There's the type that was invented by Fry Otto and developed with Ted Happold for the Mannheim Festival grid shell. And Ted Happold used to say, well, really that's a form of construction, that you take standard components and bend them into shape. And the bending into shape is what leads them to be termed strained grid shells or elastic grid shells. So Sigrid Andersen in her book on grid shells uses the term strained grid shell, which I think is a good term because this is a structure that starts with no stress in and it's strained into shape. To do that, the pieces of wood need to be small enough to be bent, and so inevitably this form of construction leads to a very light structure with small pieces of wood, even though they're connected together to make them composite and deeper and stronger in their permanent condition. Essentially you're bending small bits of wood into a shape. So I see that form of construction as something that's suitable for creating very long span, very lightweight structures, ephemeral structures. The other way of making a grid shell, in other words a shell that's formed of grid components, is to fabricate it. And if you're using material other than wood, then you have to fabricate it because it's too stiff to bend into shape. So a steel grid shell, like the one on the Great Court of the British Museum, is fabricated in shape. You put up a scaffolding and you fabricate the pieces and fix them together at their nodes to create a structure that is very like a strained grid shell, but it doesn't have stresses built into it. And because it's fabricated into shape, because the pieces are prefabricated and then brought to site and fixed at the nodes, then this type of shell can utilize much deeper pieces of wood. So from my thinking, if you want to put a really heavy weight on the shell, if you want to put a green roof on it, for instance, then surely you want stiffer elements. It makes sense to prefabricate it. You're going to end up with a structure that's not so lightweight, but is just as valid because it's designed to carry particular weight. I suppose the bigger the weight a shell carries, the better it is to move towards a catenary type structure, because if you have a large dead weight, then it's better to resist that through compression within the shell rather than bending. So another aspect of putting a heavy load on a shell might well be that you adjust the shape towards a catenary structure, so not a wavy shell of the sort that you see at Savile Building, where there's a change in stress from compression to tension in the domes to tension in the valley, but more like the Mannheim shell, which is a catenary shape, but only carries a light load. But actually the shape of Mannheim, because it is funicular, means that it would be a better structure for carrying a heavy load. But nevertheless, because it was bent into shape, it's a very light structure, and is better suited to just being a surface rather than putting a big load on it.